So today we are finally discussing the question of, is water wet? And me in video game design, as I'm a technology teacher, and discussing the impacts of technology and how that expands different people hearing different opinions. So we're talking about that. Is water wet? And the theory we have come up with is no, water is not wet. Let me explain why. Again, because our theory of moistivity. So let's begin with water, dictated by blue. If water, and here's our water surface, is right here, and we have water underneath, and we're going to have surface at the top. We have object, dictated by O. Object most of the time as we talk about is a human. Let's talk about a human as object. Is this object wet? And some of you are obviously saying it's in water. Of course it's wet. Not true. Because water, or being wet as a definition, is being saturated or covered with water. Therefore, you would think if this object is wet, there would have to be the water molecules attaching, saturating, covering this object. However, if this object were to move within water, would these water molecules, this section of water, stay with it no matter where it moved? And that answer is no. Because as this object moves around within water, the molecules stay there with itself, and they'll move a little bit. But as they move, the rest of the water, no matter where it's at, will then start covering. So, is the water sticking to it? Is it saturating it? Is it covering it? No, because different water is coming in. So therefore, it cannot saturate, it cannot cover. Underneath water, when engulfed in water, no, an object is not wet. Okay? So here's where our theory of moistivity comes in. Because what makes an object wet? As you come out of water, there has to be something. So, as this object, a human, comes up out of the water, we have this thin line invisible theory called our layer of moistivity. And basically, what is this layer? It's just the surface of water. But the idea, we make it a little thicker, the idea is that as this comes up through and it comes up into the surface, that is the moment that water binds itself, saturates, covers the object. Therefore, as you come out here and you have your object, in blue again, then it's actually going to be covered in all of your layer, in the water, in the green, the moistivity. That is when objects start becoming wet. Okay? Followed along? Now, not only is water or the layer of moistivity going across, we also have the issue that water comes in shapes of all four sides. And Brett Hawksworth, the student in this class, is actually going to come and explain to you why this theory does not only cover the top, but covers all four sides of water. Layer moistivity, part one. Here.
Okay, so basically, we have cube, right? This cube is filled with water. This cube is stationary, so there is no movement whatsoever, which adds in the layer of moistivity, which is there. It is on all four sides, on every body of water, no matter what. Oceans, seas, ponds, lakes, river, stream, whatever. When this layer is broken from any surface tension, whatever it might be, this is making things wet. Whether it enters the water, it is not creating the object wet, but after it leaves, entering the air out there, that is what makes things wet. So let's get into oceans, right? It's a big body of water. The pond, for a better example, because it's smaller. We have the water here, right? Goes all the way around. But at the bottom, there is still the layer of moistivity there. This layer is broken by rocks, sand, whatever it might be, saturating the water, saturating rocks, saturating everything at the bottom and edges. So let's get on to a cup. Cup is filled with water, right? If this cup would tilt and dump out So spilling out the water, right? This is breaking the layer of moistivity, creating moisture in there, leaving water at the bottom, right? Because there's always something left at the bottom. That is the layer of moistivity. It's the leftovers, right? Because it is literally the surface of the water. It is impossible to leave all of the water out of the cup without another interference between the water and the cup, or the object, or whatever it might be. Well, that's the end of part 1. If you have any questions, comment down below and we'll answer them in further videos.